Okay, so this video will discuss about the composite function, where I believe that most of us have learned it before, okay, maybe in secondary school. Alright, okay, so let's say we are having two functions, f and g, and then the composite function denoted by f composite g is actually we are putting the function g in the function f, so we call it as composite function fg. Alright, and then for all the composite function, right, okay, we can actually present them in an arrow diagram. Right, so I take f composite g as example. How can I sketch the diagram for f composite g? So basically it's like this. In short, we are having a set of value x, right? And then we are having a set of value y. So basically, composite function means that start from the value x, I send it to value y. I map it to value y by using the function g first. Okay, so although you can see that the g we write on the right hand side, but actually the function count first is actually the g. After you send x value to y value by using g, the function g, and then we have another value here, sending the y to maybe another set of value z by another function, which is function f. So this is what we call it as the composite function fg. So again, composite function fg means the function g comes first, sending one value to the image, okay? And then after that, we use the image, sending it to another new image by using the function f. So that's basically the concept of composite function fg. Alright, so if you have a look for this arrow diagram, right? For the first set of data here, this one you can see very clearly that it is actually the domain of g. If you only look for the function g, this is actually the domain of g. And when we send this set of value to the second set of value here, this is the range, right? Okay, and this range basically you can write as the range of g. Okay, then now if we try to observe function f now, this particular set of data or the values, it is actually the domain of f. Okay, and when you are sending this value, this set of value into the last set of value, the range or the image, then this basically, if you only look for the function f, this is actually the range of f. Okay, therefore from here we can actually observe one important result. Okay, so one important result for the composite function fg. What can we observe from this set of data is basically this one. You can see that these two, the range of g and the domain of f, right? They are actually seems like coming from the same set of data. So there's one important result where you should know, which is the range of g should be equals to or smaller to, but it should be equals to, usually when you answer the question, you use the equal, should be equals to the domain of f. By right, it should be equal to or smaller than. Alright, but when you want to solve for any question that is related to this concept, right, we usually use equal sign so that you can solve it. Okay, so you need to know basically this is an important result, and we'll discuss a few more examples on this, okay, maybe in the next video. Right, but no matter how, we need to know the basic idea of the composite function first, where we put the function g into the function f, or maybe we go through the function g first, then followed by the function f. Okay, alright, so if you have a definition here, a simple one, right? They are saying that f composite g only exists if the range of g is contained with the domain of f. This is what I mentioned earlier. Okay, the range of g should be equals to or a smaller set of the domain f, or inside the f, domain of f. Okay, but when we try to solve the question related to this concept, usually we need to use equal sign so that you can further solving it. Alright, okay, then the domain of fg is always the subset of the domain of g. So you can see that the domain of fg is the subset of domain of g. It is because of, the result is because of this one. Okay, when we look for overall, right, from the starting point to the ending set of data, this whole function here is actually f composite g in blue color. Therefore, the first set of data here is actually also the domain of F composite G, right? So from here, you can see that F composite G, okay, should be equals to or a smaller set of the domain of G, like it should be inside so that the function exists. All right. Yeah. So for this video, we will be focusing on discussing a few example. How are we going to apply composite function? All right. Then for the next video, only we will proceed to the question that is related to the domain and range in the composite function. Okay. Right. So let's have a look for example 19. Okay, so we are having the function f and they give us function f equals to ax plus b, where a and b are constant. It is given that, okay, we are having these two values lah. F2 equals to 1 and also F5 equals to 7. So find the values of A and also B. Okay, so before we can find out the values for A and B, basically we need to know when they give us F2 equals to 1, means that the x in the function f now become the 2 and the result is 1. So we can use this information okay, to try and find out the A and B. Okay, since F2 equals to 1, right? So what is my fx? So fx is ax plus b. Now they are having f2. F2 means that the x become 2. Therefore, the x here become 2. I will have 2a plus b. And this result is equals to 1. Okay, so we are having this as the first equation. Alright, then for the second equation, now they say if f5 equals to 7, that means I try to substitute the x by using 5. Okay, so f5 equals to 7. That means for the f5, the value x here, I want to change it become 5. So I'm having 5a plus b, which is equals to 7. And this is my second equation. So from here, you can see that by using the information given inside, I actually get the two equations separately. Okay, so we are having these two equations here. So we can solve these two equations simultaneously to get the value for A and B. Okay, so I think it is quite straightforward for this question. Right, so I will take equation number 2 minus equation number 1. If I take 2 minus 1a, I will have 5 minus 2, I have 3a. So 3a equals to 6, where a will be equals to 2. Okay, and after that, of course, we can try to find the value of b. So b is equals to 1 minus 4, which is equals to negative 3. So for this question, you should have a equals to 2, b equals to negative 3. By setting the question, setting up the equation using the information given in the question. Okay, so we solve it simultaneously to get the answer. Alright, then we can proceed to part number B. Okay, so for part number B, they want us to solve the equation for f(x) equals to 0. So f(x) means f composite f. Alright, which means that we are putting the function f(x) into the function f again. Alright. Okay, so before we start, I just want to recall back what is my function f(x) here? Ax plus b, right? And since we already know the value for a and b, so it should be 2x minus 3. Ax plus b, so 2x minus 3. This is my f(x) function. Since they give us the information where f(x) equals to 0. Okay, which means that now I want to put the function f(x) into the function f. So for the first f here, I just write as f. Then for the second function f(x) here, I will put it in the bracket where it is actually 2x minus 3. That equals to 0. Okay, and now if you try to continue to observe for the next step, right? F bracket 2x minus 3 equals to 0. What does it mean? Okay, so you need to aware that if I'm having f(x) equals to 2x minus 3, then if I want to put the x become the apple, then I'm having 2 apple minus 3, right? Okay, if I want to put f star, that means I'm having 2 star minus 3. That means you replace the x by using the variable that is defined in the function. So f apple become 2 apple minus 3, f star become 2 star minus 3. And now I want to have f 2x minus 3. So how can I replace my equation here? Therefore, it will become actually 2. And then the bracket here, the x, I will change it become 2x minus 3, then minus 3 again. So that's the meaning of putting the function f into another function f, right? Okay, so since now I know that putting 2x minus 3 into the function, it will become 2, then 2x minus 3, then minus 3 again, it is equals to 0. Okay, and since we already carry out the composite function ff already, okay, so we can try to expand everything to get the value of x. So if I didn't do any careless mistake, right, the value of x here should be equals to 9 over 4. Right, so this is how we actually carry out the composite function. So this is actually one basic type of question that involve the composite function. So you need to know, basically, ff means put the function f into the function f. Alright, like what I show you here. Okay, right, so this is what we have for example 19. So we can discuss the next example here. Okay, example 20. Okay, so for example 20, they are saying that f and g are defined by these two equations here. Okay, one is linear, another one is actually a reciprocal function, 9 over 2 minus x. Okay, so first they want you to find the value of k, which the equation f g x equals to x has two real roots. Okay, so to answer this question, basically what I need to do is I need to try and find out the f g x first. So what's the meaning for f g x here? So f g x means that I want to put the function gx, 9 divided by 2 minus x, into the function f. Okay, so if I want to put the function gx into the function f, then my 4x minus 2k will become 4 gx, which is 9 over 2 minus x, then minus 2k. Okay, and now for this question, they are telling us that f gx equals to x. Okay, I need to form the equation for f gx equals to x. Since this is given by the question, right, so I'm using this information to start. Right, so my f gx is this one. So if I simplify, I'll have 9 times 4, which is 36, divided by 2 minus x minus 2k equals to x. So this is my f gx equals to x. And then according to the question again, they are saying that we have two equal roots for this particular expression. So for two equal roots, for this keyword, right, we actually know that you can link it with the concept where discriminant b squared minus 4ac should be equals to 0. But to apply b squared minus 4ac, this discriminant formula, you need to express your equation into a quadratic equation. So this is not a quadratic equation yet, right? So I want to change it become the quadratic equation. How can I change it? I multiply the whole expression or whole equation with 2 minus x. So that the denominator 2 minus x will disappear in my equation. So I'm having 36 minus 2k multiplied with 2 minus x, and then equals to x multiplied with 2 minus x. Okay, so this is what I have here. And then now I will want to expand this whole equation and try to rephrase it. Okay, so I will not show you the detail here. You try to expand everything and try to rephrase it. By right, you should be able to get a quadratic equation, something like this, which is x squared plus 2k minus 2 x, and then plus 36 minus 4k equals to 0. Okay, so to get until this step, basically you need to expand everything here and then you rephrase the equation. Okay, then you put the highest power of x in front, which is x squared minus 2k minus plus 2k minus 2x plus 36 minus 4k. So from here you can see very clearly that this is a quadratic equation. Okay, when I already have the quadratic equation, right, Okay, when I already have the quadratic equation, then I can continue, okay, to use the discriminant formula. Okay, because for this question, they are saying that we are having two roots, okay, when f g x equals to x. So from f g x equals to x, you can replace it, become a quadratic equation. Therefore, now you can start using b squared minus 4ac equals to 0. Okay, so if I let b squared minus 4ac equals to 0, what is the b in my equation here? 2k minus 2. So I'm having 2k minus 2 square minus 4. What is the a? A is a 1. What is the c? C is 36 minus 4k. So 36 minus 4k, and I let it equals to 0. Okay, so again, for this question, they want you to find the value for k, right? So you are already having one equation in terms of k already. Okay, please expand all the square here, expand every single term here, okay, and rephrase your equation. By right, when you try to rephrase all your equation here, you should have 4k squared plus 8k minus 140 equals to 0. Okay, then if you get this equation, then you can further simplify it. Okay, so you're having a quadratic equation in terms of k. Now they want you to solve the value for k, or find the value of k. So I think what you can do is solve the quadratic equation in terms of k. So I'm having k plus 7, and then k minus 5 equals to 0. Therefore, I have two values of k, where k equals to negative 7 and also k equals to 5. Okay, so this is how we actually get the value for k. And in our step, we actually includes the composite function concept, because the equation given here has a composite function here, fg, right? Okay, then after you get a value for x equals to negative 7 and k equals to negative 7 and also k equals to 5. So proceed to part number 2. Okay, for part number 2, what they want us to find is, they want us to determine the roots. Okay, so again, determine the roots. The roots means the value of x. Okay, for this particular equation, for the values of k found in part 1. Okay, so now if I have k equals to negative 7 and k equals to 5, right? If I want to use these two values of k to find out the x, I have to replace it back into this quadratic equation. If you have k already, then you can solve this equation, then you get answer for the x, where the answer for the x is actually the root. Okay, so now here I'm having two parts of solution. First one is when k equals to negative 7, okay, so please substitute into this quadratic equation so that I can further simplify this equation and get the answer for the x. Okay, so when k equals to negative 7, right, if you substitute into this particular equation, by right you should have x squared minus 16x plus 84 equals to 0. Sorry, I think this is not 84, it should be 64. Okay, so 64 equals to 0. And from here, if you try to factorize it, you will have x minus 8 and also x minus 8 equals to 0. And then your x is equals to 8. So this is the first answer for the 8. For the x, when k is equals to negative 7. And by right, you should have one value for x only for a value of k, because they already mentioned, right, to find out this when the composite function equals to x is having two equal roots. So that means when you solve for the roots, you should have two equal roots here, x equals to 8 and also x equals to 8. Alright, therefore eventually you have only one answer, which is x equals to 8. And now for the second value of k, okay, so we now want to substitute another value for k. When k is equals to 5, what is the value for x? So again, substitute into this particular equation here, you should have x squared plus 8x plus 16 equals to 0. And after that, we're having x plus 4 squared equals to 0. And therefore, your root for this particular quadratic equation will be x equals to negative 4. Okay. Yeah, so basically this is how we solve example 20 lah. Okay, so you can see that this part of the question actually they involve the composite function as well, but of course they also bring in some other concept that we learned earlier. As an example, when you're having two equal roots, means that your discriminant b squared minus 4ac in the quadratic equation should be equal to 0. Okay, and then also you need to learn how to factorize the equation to get the root. Alright, so you can see that this question basically combine chapter 1 and chapter 2 together. Besides the composite function, they also want us to use the concept of discriminant when having the two equal roots. Alright, okay, so we'll stop here for this video. So next video, we are going to discuss more example on composite function.